Very good morning to everyone. I heartily welcome all the online and offline participants. Are you able to hear me, sir? Anybody? Is it audible?
Yes, sir.
Yes, sir.
It's audible.
Hearty welcome to all of you, online and offline participants across the country, across the globe. And this is a special brainstorming session organized by Indian Institute of Rice Research and Society for Advancement of Rice Research. We are organizing these meetings regularly for the benefit of rice workers across the country. And you all know the importance of this DSR in coming years and also at present. I heartily welcome all the delegates, and we are seeing many senior colleagues of rice research and also society members and AICRPR cooperators across the country, and a special invitation to our IIRRR group, which is led by Virendra Kumar, Chalab Dixit and Sudhanshu, who are ready to share their experiences. I also welcome many, I think our own earlier directors of this institute and all the cooperators of this rice research. We were expecting our DDG TR Sharmaji or Dr. SK Pradhan. Maybe because of that maize workshop, they must be having very tight schedule, may not be maybe joining in due course. Due to this, I request our honorable director, our RM Sundaram, to chair the session, and AK Nayak, director NRRA, to be the co-chair the session to make this proceedings of the brainstorming session. Now I request our director, Dr. RM Sundaram, to give his inaugural remarks as the chairman of the session. Thank you, sir. Thank you, one and all.
Respected Dr. A.K. Nayak, Director ICAR-IIRR, team members from NRRA, Dr. A.K. Singh, Director IRI, who is expected to join very shortly, and also the team from ICAR-IIRR, my dear colleagues and cooperators from All India Coordinated Research Project on Rice, Dr. Sudhanshu Singh, Dr. Virender, Dr. Vikas, Dr. Shalab, and other team members from International Rice Research Institute, and all the staff of IIRR. On behalf of ICR Indian Institute of Rice Research, All India Coordinated Research Project on Rice, and also on behalf of Society for Advancement of Rice Research, which is organizing today's brainstorming session, extend a warm welcome to each one of you for this important brainstorming meeting. We all know that direct seeded rice has been in vogue for last several years, particularly under upland conditions. But of late, we are seeing its increased adoption even in irrigated areas or even in other ecosystems also, particularly after the 2 waves of corona hit us, particularly in the states of Punjab and Haryana. And we are also seeing its increased adoption even in the southern states like Andhra Pradesh, Telangana, and some parts of Tamil Nadu and also Karnataka. What's my expectation or anticipation is that this is going to be one of the important or major crop establishment system, maybe in another 8 or 10 years, wherein it can be expected that possibly more than 50% or 60% of rice area will not be under transplanted cropping system, but under direct seeded rice. It has many advantages over the present methodology of taking up a nursery and then transplanting the crop after 25 to 30 days. It can save a significant amount of water. It can also save significant number of labor and also result in cost saving. On the other side, there are also new problems which we can anticipate because of direct seeded rice, like the problem of non-germination under anaerobic condition, particularly when direct seeded rice depends on ambient rainfall. That could be a major problem. And other anticipated problems are increased incidence of nematodes when particularly soil will be with only residual moisture. It will not be under flooded condition. And there could be other problems like increased prevalence of certain pests and also diseases like brown spot and others. And direct seeded rice has also provided an opportunity in terms of developing customized mechanization tools, in which I would appreciate and recognize the role played by Pranadhara Foundation, from which Dr. Pundari Kakshudu is here. Sir, you're also welcome for this particular meeting, sir. And we'd also like to hear views from Pranadhara and your good self about your views on possibilities and limitations of customized mechanization in DSR. And what we'll have is, in the initial part, the whole meeting will be moderated by my colleague, Dr. Mahinder, who is head agronomy and also crop production. We'll be having introductory talks by dignitaries like Dr. Naik and others, after which we'll have 3 or 4 committed presentations, very short presentations. One by Dr. Sudhanshu Singh, Director, IRRI South Asia Regional Center, who will be giving a brief introduction about the possibilities and limitations of direct seeded rice. Then it will be followed by Dr. Virender Kumar, who will be talking on the crop production or agronomic aspects related to direct seeded rice. And that will be followed by a short talk by Dr. Shalabh Dikshit and team of Dr. Vikas Kumar Singh on what are all the breeding related traits which you should focus for direct seeded rice, both wet, dry direct seeded and then wet direct seeded. Then that will be followed by Dr. Mahendra Kumar, who will be sharing the experiences what the 3 institutes, IRA, NRRA, and then ICAR-IIRR gained from DSR studies in AICRPR. And that will be followed by a structured discussion among all the cooperators or all the online and offline participants, or topic wise, which will be announced by Dr. Mahendra Kumar in the due course when the discussions will be starting. With this brief introductory remarks, I now invite Dr. A.K. Naik to kindly offer his remarks, sir. Naik, sir.
Okay, thank you very much. Of course, our DDG is not there. He's likely to join. Respected Professor T.R. Sarmaji, DDG Crop Science. Respected Dr. S.K. Pradhanji, DDG FFC, who is likely to join shortly. Dr. A.K. Singh, Director IRI, and Dr. R.M. Sundaramji, Director in Indian Institute of Rice Research. Other dignitaries and distinguished scientists from IRRI. I am thankful to organizer inviting me to this brainstorming session and inviting me to co-chair the brainstorming session. So it is a most relevant topic of the day. DSR is not a new technology. It is a very age-old technology, as old as the domestication of rice. And various form of DSR is practiced time immemorial in India. Mostly it is practiced in rainfed area. Dry DSR, wet DSR, DSR with bewsuning. These are the traditional practices are being followed by the farmers. They have invented this particular technology. Of course, subsequently, the modern DSR, what we called with the line sowing with tractor mounted or power tiller mounted seed driller, that recently it is the talk of the day. When we were talking about rain-fed rice, the farmers are practicing this rain-fed rice not out of the benefit they are getting from DSR, but out of compulsion. Particularly in case of rain-fed lowland rice, farmers, they used to sow the seed much before onset of monsoon with very huge amount of seed, even to the tune of 100 to 120 kg. And again, they wait till the rain comes. When it rains, then again the farmer, they just wait till the seedling grows to the height of 30 centimeter or 30 or 35 days after germination. Then they go for bewsuning. Again, that's a tillage operation typical to the state of Chhattisgarh, Odisha, part of West Bengal and Jharkhand. These are extensively followed in rain-fed lowland or semi-deep water or deep water paddy. And this is sometimes when it is not possible, window of opportunity is not available for dry DSR, and the farmers, they go for wet DSR in some area. Of late, the DSR is given a renewed interest because of 4 or 5 drivers are there. One is the cost of cultivation for transplanted rice is very high. Now labor requirements also very high. If you are going DSR, then your 1/3 of cost of cultivation, that is starting from 1/4 to 1/3 cost of cultivation is reduced if you are going for dry DSR. And the second thing is transplanting is involving a lot of drudgery. If you are putting a women workforce for a period of 10 years transplanting, you are taking away 2 years from her precious life. That is involving so much drudgery. So that is driving. Labor unavailability is driving why we should go for a DSR. And of late, why there is a renewed interest not only from our agricultural scientists, from different companies, because your IPCC has recognized DSR is one of the decarbonizing practices that is have a lot of potential to decarbonize Indian agriculture. If at all Indian agriculture has to decarbonize, which is contributing to the tune of 19% of the total GHG emission from our economy, and the rice is contributing to the tune of 15 to 17% GHG emission. And in case of enteric fermentations, GHG emission from the enteric fermentation, the ruminant animals, there is very little scope. At present, the technology is not developed much to reduce the GHG emission from animal sector. So only left is your rice. So that's why large number of companies, they are coming so that this decarbonization initiative that is being taken up, and they can convert it to carbon credit, commoditize it, and they can be sold in the stock market. Of late, the Bayer and Indigo India and some Japanese companies, they are taking these DSR in a big way. In fact, some of the companies, they have already started trading it. The voluntary carbon credit markets, now it is open for our Indian farmers. Because of the amendment of Energy Bill 2022, now it has opened up avenue for rice farmers for carbon farming. And then with this opportunity, our scientific community, policymakers, they will have to come up and fine tune with the market availability and develop the strategy protocols, how this can be inventorized, how this can be, registry can be developed, and it can be traded. So I think with this platform, I will be requesting our scientific community and policymakers that we need to inventorize this carbon credit, which that can come out from the rice farming by converting DSR to different form of transplanted rice to different form of DSR. What are the potential of those carbon credit? Whether we do have at present in India those registry for maintaining those registry, or so as I have heard, many companies, they are registering these carbon credit in USA. So that's a very negative thing. So our resources are being inventorized and registered in other countries. So our government and ICAR has to come up with a policy decision how that has to be inventorized, and again registry has to be prepared so that the carbon credit benefit can be given to our farmer, particularly those who are going for DSR rice. And we know why that there is a renewed interest in DSR. IPCC has already included DSR was one of the carbon accrediting or decarbonizing practices. And in future, if at all we want to go for net zero emission from agriculture, your rice sector is one of the key sectors from where we can go for decarbonizing our agriculture and achieve net zero emission. Government of India has already given a timeline by 2070, India has to achieve the net zero emission. So much before the economy achieve net zero emission, our agriculture has to achieve the net zero emission. If agriculture has to achieve the net zero emission, then the rice farming has to achieve net zero emission much before that. So at least this forum can think of whether we can put a date by 2047 when India will be celebrating its 100 years of independence. Can we make Indian agriculture net zero emission? And for that, the rice has to attain the net zero emission, and DSR is one of the potential technology, not has been identified by our scientists, is globally recognized. DSR is having potential to reduce GHG emission by 20 to 25%. Of course, indirectly, it can contribute to a larger extent, because 25 to 30% of water can be saved if you are practicing DSR. It could be if it is light textured soil and heavy textured soil, the percentage can vary, but invariably there is a saving of water. So with this, I think we will have to prioritize some of our research with respect to development of agronomy, development of the varieties. And we know if you take Asian rice, Southeast Asian or South Asia into consideration, India is a country with least DSR under its plow. But if you take Sri Lanka, take Bangladesh, even Thailand, some other Southeast Asian country, the percentage of DSR is much higher there. But in India, we are having a less. A conservative estimate says it is around 12 million hectare of Indian rice is under DSR, different form of DSR. I am not talking about the DSR that is the modern DSR that is being followed in Punjab, Haryana recently, but the DSR that is traditionally followed, if you take those areas into consideration, it may come around 12 million hectare. And there is a potential for increasing this DSR to the tune of another 15-20 million hectare. If it is backed up by good policy and again research backup, then 20 million hectare of additional area can be brought under DSR. And if you are bringing, we are bringing 20 million hectare of rice, I think 1 hectare of rice is having saving of 1 ton of carbon dioxide equivalent, and that is equivalent to 1 carbon credit. If you take a carbon credit market into consideration, the voluntary carbon market is providing $30 to $40 per carbon credit. Vera in USA, they are providing. In fact, some of our company has already signed memorandum of understanding with USA company, and they have registered it. From rice sector, they are trading the carbon. I can take name that Indigo India, they have already done this. So now our policy backup and the scientific input has to be tuned with the development that is taking place in the market. The carbon market has to be streamlined, the inventory has to be prepared, and the registry has to be maintained. The whether we can trade the precious commodity which we are inventorizing in India, or we will have to sell it in the abroad. So that decision has to be taken, because every country is having its limited carbon space. But at present, India is having some carbon space, whether that can be traded internationally or that can be traded in India. That decision has to be taken. And when we are talking about rice and direct seeded rice, some policy guidelines or some kind of advisory through ICAR, it has to go to the government of India. Again, my colleague Dr. Sundaram already narrated that the DSR is having multiple advantages. Irrespective of its carbon accrediting potential, decarbonizing potential, DSR is having other multiple benefits like reducing cost of cultivation, reducing drudgery, saving water. So these are the benefits which are associated with. But what are the barriers? Why the technology is not going well? In Punjab also, during the COVID period, the incentives were given there to the tune of 1,500 to 2,500 per hectare. But despite that, it is not going up well there. So these are the, then we need to introspect why this technology is not moving. What are the barriers? Of course, we know there are different barriers. It could be a non-uniform your crop establishment, seedling establishment. Weed is important problem. Then in case of rain-fed rice, the narrow window, there is a window of opportunity during the seeding operation. It is very narrow, because if there will be rain, then it doesn't provide opportunity for direct seeding. So whether there will be a role of mechanization, whether there will be a role of anaerobic germination rice, whether we need to develop the early vigor and weed competitiveness. Then at present, we are developing again herbicide tolerant rice, whether that could be one of the approach. So these are the things, researchable issues. Simultaneously, the crop development priorities and the development of agronomies that suit to your DSR that needs to be developed. And the carbon fair farming, the opportunity which has been given to our farmer, we will have to provide this benefit to the farmers if we our extension functionaries, the research recommendation from the laboratory, and the policy initiative, if that can be they can be streamlined, I think this benefit you can provide. I told that that is the additional benefit. If you 1 hectare tentatively we have estimated, you see the greenhouse gas estimation in terms of carbon dioxide, nitrous oxide, and methane, if you take into consideration, 2,000 kg carbon dioxide equivalent per hectare to 3,000 kg carbon dioxide equivalent is there. So if you will see DSR and transplanted rice to the tune of 1 ton, so multiply 1 credit with $40. So you can see so around 2,000 to 3,000 rupees per hectare we can provide to the farmer. That's a precious amount of money, besides the reduction in the cost of cultivation. So that is a tremendous opportunity. Our research priorities have to be tuned with the market potential that is being available to us. With this, I think I will again once again congratulate Dr. Sundaramji for taking this initiative and conducting a brainstorming session. So in future, we can reprioritize some of our research, the way we are conducting our breeding trials. Most of the breeders they do test their varieties by transplanting. So why can't there be guidelines developing methodology in under DSR conditions? We need to test our varieties, and sometimes our the AICRP trials that is being conducted under DSR. So for irrigated and non-irrigated, the trial can be all separated because those two ecologies are altogether different. So these kind of things, many questions will come from different scientists. We can deliberate on and take informed decisions so that in future our research priorities, extension priorities, and also the policy backup can develop from this kind of discussion. Thank you very much.
Thank you very much, Dr. Naik. You have captured all the points very nicely. And I would like to remind everyone that this is an event not just organized by IARR. It is an event organized by all the 3 stakeholders, that is IARR, NRRI, and also IRI, who are partners in the area of rice research and also stakeholders related to rice. And I'm also happy to say that there are many members from IRRI India and also from IRRI Philippines who have joined this meeting. So for the next part of the presentation, Dr. Mahendra will take over. I would just like to know, Dr. A.K. Singh, sir, are you there, sir? Or anybody from IRI is there? Would just like to, Dr. Gopal, are you there? Dr. Gopalakrishnan, are you there? Sir, are you able to hear me, sir? Can anyone confirm whether I'm audible?
Yes, sir, you are audible.
You are perfectly, you are perfectly audible.
Whether anyone from IRA has joined this meeting? Okay, what we can do is we can hear in due course. Dr. Pradhan, sir, have you joined, sir? Dr. Pradhan? Okay, I think he'll join in due course. I now request Dr. Mahendra Kumar to proceed ahead with Dr. Mahendra Kumar will serve as moderator for today's session, and he'll proceed ahead.
It is working. Once again, I also welcome our. Okay. I also welcome our rapporteur to record the proceedings, Dr. Mangaldeep Tuti and Dr. Sridevi. They will be recording the proceedings of this brainstorming session. First of all, we'll let us hear from IRRI perspective on DSR. I think Dr. Sudhanshu will take lead. I think, may I request Dr. Sudhanshu to go ahead for his presentation? Dr. Sudhanshu Singh. He will speak first. Sudhanshu or Virendra.
Okay, like all 3 will speak one after the other.
So okay. No, I request our Dr. Virendra Kumar, research leader, IRRI Philippines, will be speaking first. Dr. Virendra ji, go ahead, sir. Okay.
Sir, can you go to full screen? Dr. Virendra, can you go to full screen, sir?
see the slides?
Yeah, we are able to see now, sir.
Okay.
Sir, kindly start your presentation.
Okay. Thank you, sir. So first of all, on behalf of IRRI, I would like to thank Dr. Sundaram and Dr. Mahendra for inviting us and giving this opportunity to share work which we've been doing on DSR. And this would be a joint presentation from Dr. Sudhanshu, Dr. Shalab, and from myself. So I will start and I will talk about the issues and challenges and some of those evidence base where DSR performance stands. And then Shalab going to talk about breeding aspect. And then Dr. Sudhanshu going to talk about some of the scaling approach we have been following to promote direct seeding in India. So let me start with, it's not moving. Okay, so if you look at, there are few flagship IRRI has prioritized, and direct seeded rice is one of the flagship program we have, which shows that direct seed rice is very, very important from IRRI perspective. And the flagship idea is basically to have a integrated approach where we combine the transdisciplinary knowledge, resources, and talent to fast track the delivery of the high value products. So here we're talking about integrating a team, doing research to delivery from genes to landscape. So gene discovery to variety development to management options to scaling. So direct seed rice is one of the flagships out of the 4 flagships IRRI has identified for the coming years. Now I'm talking about why we're talking about direct seed rice and what are the drivers why farmers or even scientists are shifting from transplanted rice, which is the most dominant method in India, to direct seed rice. And the drivers are, we know that labor shortage, water shortage, economics, because cost of production is increasing in transplanted rice. And also Dr. Nayak just, Nayak just talked about carbon credit. So mitigation is another drivers for us, for scientists, to shift from transplanted rice to direct seed rice, because transplanted or paddy rice is one of the major contributor of methane emission, which is a potent greenhouse gas responsible for climate change. So these are the drivers why we are shifting from transplant to direct seeded rice. Very quickly, what are the benefits of direct seed rice compared to transplanted rice? And this is based on some of the meta-analysis and also some of the recent data from different projects. And if you look at it, if managed well, DSR can yield similar to transplanted rice. It can save water from 20 to 25%, but can go up to 50% if managed precisely. Labor saving, because no need of transplanting, nursery raising, and uprooting of seedlings. It reduces cost of production and increases net income of the farmers, ranging from 100 to 120. This is net sell, but it will vary from geography to geography. I'll talk about that later. DSR is also better adapted to climate change, where there's a flash flood or dry spells, and has several environmental benefits. It reduces methane emission anywhere ranging from 30 to 98%, depending on the hydrology, the water dynamics in the field. There's slightly higher nitrous oxide, but the amount of nitrous oxide is small. So overall global warming potential is much lower in direct seeding than transplanting. It reduces drudgery, and interestingly, it has a positive impact on the succeeding non-rice crop. So for example, in rice wheat systems, what we observed that when you grow wheat after dry direct seeded rice, the yield was on average 9% higher than when you grow wheat after puddle transplanted rice. So in system level, there's a positive impact. Despite these several benefits, there are still challenges and trade-offs associated with direct seeded rice. And one of the trade-off is crop establishment. One of the advantages in transplanting is that you assured crop establishment because you're transplanting seedlings. And if any crop, if you're a good establishment, the likelihood of success is very, very high. In direct seeding, the establishment is the key. So achieving good establishment is a challenge, and it can be affected by your seed drill, quality of seed drill, depth of seeding, land leveling, and also could be affected if there's a heavy rain after crop establishment, if field get inundated, because rice is sensitive to flooding at early stage. Once it establishes, it can tolerate flooding, but not at germination or establishment stage. We know that weed management become a big issue, and this is one of the major constraints in adoption of DSR. Another issues, as Dr. Sundaram and Dr. Nayak has talked about, is micronutrient deficiency, nematode problem. In addition to that, most of the varieties which are we using are developed for transplanted system, not yet developed for direct seeding system. So availability of varieties suitable for DSR. For scaling purpose, availability and access of seed drills is an issue for large scale adoption. Another trade-off is we reduce the methane emission, but higher nitrous oxide. So how to address this trade-off so that we can even get more carbon credit that Nayak was talking about. If we can further reduce nitrous oxide, I think we can increase the carbon credits. And then I think still more work to be done on precision water and weed and nutrient management to push the productivity frontiers in DSR. To address these issues, IRRI established a consortium, what we call Direct Seed Rice Consortium. And this is what we call Partnership for the Sustainable and Resilient Rice Systems. And this is a public-private research for development consortium. And we finished phase 1 and we are in phase 2. And these are the partners, the members of the consortium. So you can see several key private companies, key national partners, and international foundations are member of this consortium. The goal of this consortium is to accelerate environmental sustainability, at the same time increasing profitability and resilience of rice-based system to climate change. And the vision is that we can do this by developing solutions or innovations for DSR-based systems, and then catalyzing adoption of mechanized and precise DSR through public-private partnerships. So now I'm going to talk about some of the progress what we have made to address some of the challenges. Because of time limitation, we'll highlight key component. So first is current status of DSR. And if you look at the current status of DSR, and you will see that in Southeast Asia, transplanting is not anymore the dominant. In many countries, direct seeding is already the dominant method of crop establishment. It's widely adopted. Cambodia, Malaysia, Vietnam, Thailand, 70 to 98% area of rice is under direct seeding. But this happened because of default of labor scarcity, farmers shifted, and mostly it's a wet DSR with high seed rate and broadcast. It's not mechanized and precise. And because of continuous DSR, many weed-related issues has emerged. Whereas in South Asia, except Sri Lanka, in Sri Lanka, 95% area is direct seeding. In most of the South Asian countries, adoption has been low. And we have to understand, we have to address what are the constraints in adoption. So the challenges or the issues to address are different in South Asia and Southeast Asia. If you look at, we further dive deep to understand the spatial adoption of DSR and how that varied. And we did this for 3 countries, Philippines, Cambodia, and Myanmar. And you can see that in Philippines, adoption is more in southern part of the country than northern part. And now we have to understand why is that happening. I mean, that another survey we have to do it. And we have planned to do the similar kind of study for other countries. And we discussed this with Dr. Mahendra earlier that we could do this with the Indian Institute of Rice Research using the power of AICRPR network. So because the government is not collecting crop establishment based area, but I think through expert judgment, we can collect this data, and this could be a good business intelligence for different stakeholders. Now coming to the partnership. Partnership is key for closing research gap as well as for scaling. And ICR is a member of this consortium. Under the umbrella of ICR, we have created this network around DSR, Research for Development Network. And our presence, our partnership is in 13 states, from north to central to southern to eastern India. And we have more than 20 partners, we are working with. And ranging from, we're doing activities from research, scaling, capacity building. And these are the topics we have been working with different partners. Quickly now, the performance of mechanized DSR over farmer practice. And this is part of our evidence base, where the DSR stand compared to farmer practices. That could be transplanted rice, or it could be behusening, which that I talked about in Odisha and Chhattisgarh. So the benefit of DSR can vary. I mean, the benefits are diverse, and it varies by geographies or ecology. And the first example is Odisha and Chhattisgarh. In Odisha, about 40% area is still with behusening system, and probably in Chhattisgarh, anywhere 60 to 70%. So significant area in these states are under this traditional method of crop establishment called behusening method. And I don't need to go in detail because that Naik has already explained about this method. This practice is labor intensive, uses high seed rate, and with a little lower yield. So then we thought of drill DSR with more precise management could be a good solution to improve the productivity and profitability. And we have a project in Odisha. Last year, we did demonstration in 3,000 acres. And then we did crop cut, random crop cut. And you can see the performance of mechanized DSR. So the farmer practice, it could be behusening or transplanted rice. So with drill DSR, without behusening, with inbred varieties, yield jump to 1 ton. So almost 1 ton yield advantage. And then when you do the drill DSR combined with hybrid, then yield further increase. And then what we observed that the net income increased more than $300 per hectare. And similar response was observed in Chhattisgarh. So Odisha was coming from the farmer's field, real world. Chhattisgarh is on station trial, but similar response. We got 1 ton higher yield with drill DSR compared to behusening, broadcast behusening, and the net income was about $250 higher than behusening. As I said, the benefit varies by geography. If you look at Punjab, and the Punjab, this survey done, we did the crop cut in 2022 when this large adoption of DSR happened because of COVID. And that's what we found. Yield was similar across 9 districts we did it. So yield was similar in transplanting and direct seeding. The cost, this is from the farmer's field, whatever the farmers did it. So the cost was reduced by 6,000 rupees per hectare. And we observed that water saving about 5 irrigation, which is equivalent to 18%. But then we also asked how long it takes to irrigate each irrigation. And when we account for time to irrigate, because time to irrigate is more in direct seeding than in transplanting, and that way it was 10% water saving. Again, this is what farmers are doing it. Scope is more, there's a lot of gaps at farmers level in water management. So the scope to increase the water saving is huge. But what our farmer did, we observed 10 to 20% water saving. Interestingly, we observed it with the straw burning in high DSR intensity area where adoption was high. But we observed the rice harvesting shifted early, and there was more window for farmers to manage. So we observed less fire events or straw burning events in high intensity area, which show that likely if the adoption of DSR is happening in Punjab, so the fire or events may reduce. And also the global warming potential was much lower in DSR than transplanting. In Bihar, compared to best management transplanted rice, the yield was similar, but in yield was higher than farmers' practice of transplanting, which is late transplanting with aged seedlings. So in that scenario, yield was higher, and the cost was reduced by almost 8,000 rupees. Net income increased, and we observed that better adapted to flash flood and dry spells. In Assam, this is coming from on-farm trials at farmers' field, because we have a big project, a World Bank funded project there. And what we observed that in Assam also there's a yield advantage with DSR. So in dry DSR as in wet DSR, but I think scope for wet DSR is more than dry DSR because of high rainfall area. And then income gain and the global warming potential is also lower in DSR than transplanting. Odisha, Chhattisgarh already discussed in detail. And also we observed the DSR was better adapted in flush flood area. DSR survived because the crop was taller when flooding happened than transplant rice. So we observed a landscape fully flooded, only DSR plot survived, transplanting completely damaged. So based on these results, Odisha government partnered with IRRI to promote DSR, and Government of India, Ministry of Agriculture and Farmers Welfare has chosen DSR as a one technology to scale in India. DSR should not be looked in isolation, but should be looked in a system approach. And this is interesting. So we looked at a system level impact, because DSR by default enable early establishment. It has to be established before heavy rain starts. So in early June or end of May. That allows timely establishment of rice, leading to timely wheat planting and higher system level yield, particularly in Eastern IGP, because in Eastern IGP, wheat is planted late, and that's why the productivity of wheat is low. So we did survey with the farmers who adopted DSR, 100 farmers we surveyed, and you can see the time of average time of DSR sowing was 18 June and wheat sowing was 23rd November. Whereas the same farmer in their transplanted plot, their transplanting date was 5 July and the wheat sowing was 2 December. And this is the data we have, large number of data, and the planting date response of wheat. Wheat is very sensitive to planting date because of terminal heat. So because DSR allowing early establishment of wheat by 10 days, so we can expect just by early establishment of wheat, 0.4 ton yield advantage in wheat. In addition to that, if you avoid puddling, there's a positive impact on the wheat yield. So likely the yield advantage would be much higher than 0.4, but 0.4 ton is just purely because of early establishment. Now we'll talk about the varietal development, and I ask my colleague Shalab. He will talk about the progress we have made in varietal development. Over to you, Shalab.
Thank you, Virender. I'd ask the room if I'm audible before I start. If someone can please confirm.
Yes, Dr. Shalab, you are very much audible. You can go ahead.
Thank you so much. You know, Virender and even the experts and delegates before that have set the stage very well. You know, and what I'm going to do is pick up on some of those things that have been talked about already and try to connect it to the context of plant breeding here. So let me talk, you know, step back a little bit before I get into DSR, you know, breeding efforts itself. We just few years back, we started our global rice market segmentation exercise. And in that, when we were gathering that information, close to 30% of the world's rice area comes to be DSR in total. Majority of that is puddled broadcasted type of cultivation. And the range could be somewhere from 8 to 10% by in a given country up to all the way up to 98%, as we saw in the case of Sri Lanka and Cambodia. But majority of that still continues to be puddled and you know, broadcasted systems. Now, when we think about that, even before we get into the transplanted systems, we see that while there is a huge potential, as we all are discussing right now, we need to see that adequate germplasm is so critical to cut down the duration in itself, to cut down the amount of water that is needed, to cut down the number of irrigations, to cut down the emissions, and so on and so forth. And all these translate into either income or environmental benefits when it comes to DSR. So we have already covered that. So with these thoughts in mind, 3 years back, we started compiling all the genetic work that was done at IRRI in all these years, and we established the DSR breeding program. Now, IRRI currently is in the form of pipelines. So we have got 11 pipelines in total, which are, can I request?
Requesting Dr. Sridevi to
You can continue. Yes.
Okay, somehow I got muted. I'll start over again. What I was saying was that we are having 11 pipelines where we are currently working, and out of those 11, we've got 4 pipelines that are direct seeded, targeting direct seeding, and those 4 are actually presented over here along with the total area that those pipelines cover and their pipeline size. These pipeline size are basically decided by the number of crosses and number of progenies we make per 1x, and 1x basically means 7,200 progenies. So that's what this pipeline size is, and both inbreed and hybrid breeding programs are currently targeting these things. And if you look at the percentage of effort by area, we are around 30%. Same is by pipeline size. And under hybrids, actually the effort is a little higher, which is around 40%. Next one, please. So this is all about our structure. We are talking already about how current structure of the DSR and current DSR systems are. A few years back, we conducted an experiment where we planted some of the major varieties along with our germplasm, well adopted varieties under direct seeded systems with fully aerobic conditions, as well as very intermittent irrigations under puddled systems. And what we see is invariably across most of those, you'll see an yield decline starting compared to the transplanted systems. It can be less, it can be more, depending on the duration and so on and so forth, and the adaptation to low water conditions. So what that means, what I'm trying to say here is that while we have some really good high yielding varieties in the system, which are really well adopted across the board in transplanted systems, when we come to direct seeded systems, there is genetics that needs to be targeted. Same as we do in any other, specialty rice. Take an example of the basmati pipelines. Apart from the yield, you also look at so many different traits, grain quality related, and so on and so forth. We also need to have a suite of traits in direct seeded breeding material, direct seeded varieties, which will not only, help you with major problems like weed competitiveness or establishment and so on, but make them amenable to mechanization, to yield declines due to less water application and so on and so forth. Make more efficient water use and so on and so forth. Next one, please. Just one click, please. Yeah, there we go. So when we see the current elite germplasm, this is an example on the left side, the box plots that you're seeing, the bar plots that you're seeing. What you see here is that under the first box, second box, and the third box, those are basically transplanted, dry direct seeded under aerobic irrigated and aerobic rain fed trials, basically in various locations that we have conducted. And what we see is that between transplanted and irrigated direct seeded, there is a huge variation in the yield performance in the IRRI elite germplasm as well. But there are some lines that are able to maintain their yields across the transplanted as well as under the direct seeded systems, under the irrigated systems. When it comes to the rain-fed systems, of course, the yield decline happens, but there is a confounding effect of DSR and along with the rain-fed situation and abiotic stresses, etc. My point here is that we have elite germplasm in pretty much in all programs, and I'm sure that's the case in the India breeding programs as well. We need to pull the right germplasm and start breeding with those, to bring in the relevant and high-yielding varieties forward. Next one, please. We have talked in length about various issues in DSR, and this is basically, covering this slide here basically covers some of the traits that we at IRRI through various, trait-related activities in our breeding program as well. We have identified as essential traits, except for herbicide resistance, because it might have some, stewardship-related aspects as well. So we call it, very critical, but we don't, put it as a must-have right now. Hopefully in future we will have that. But in this, I would just go very quickly through early and uniform emergence under various depth of seeding, not only the normal depth, but deeper soil depth, which is basically related to mechanization aspect. When you have unleveled fields in the farmer's field, you'll have to have germination from various depths of soil. That is very critical. We have talked about anaerobic germination. We are well aware of nematode and lodging resistance, early vigor, and canopy coverage. So in our case, we are basically taking canopy coverage as one of the criteria for selection for DSR material. And we measure our canopy coverage at 30 days. And at 30 days, we are trying to get at least 40 to 50% of the canopy coverage by the crop. And we are trying to take that as our criteria for selection. Of course, drought tolerance, yield under aerobic condition, because are also the critical aspects. There are various QTLs. Clearfield, Provicia, and Robin are for the for the herbicide resistance. You're all well aware of. Many of you will be well aware of these QTLs that can be used for breeding purposes as we go along. Next one, please. And of course, early maturity, medium plant height, premium grain quality, and all those other prevalent abiotic and biotic stresses are also critical, depending on where and which geography you're talking about. Please, next one, please. So here is a checklist of traits. Under dry DSR, all the listed traits are important. Under puddle DSR, everything is important except for nematode resistance, because puddling takes care of that. Under transplanted condition, many of them are not needed. Many are, you can have it or not have it, which is the 3 dots that you're seeing. And there are some traits that are also important under the transplanted condition. So we have made this checklist, and what we try now to do is we use that for our advancement criteria under direct seeded conditions. So we make sure that, we try to bring as many as possible of these traits into the varieties when we go forward. Otherwise, just by yield is not a good idea to advance the material. Okay, next one, please. This is just a glimpse of the DSR elite germplasm. I was talking about the ones that are yielding really high and possess 1 or 2 or 3 of those listed traits. So we have actually taken those. We have actually screened more than 30,000 of lines under our DSR systems. And we have basically identified close to 1,000 lines that we currently consider as our elite starting point, which are highly DSR adopted, very diverse. As you see, this figure here, this actually shows the gray dots here are basically the full set, and then the red ones are the selected ones, which basically are high yielders, and they cover the whole diversity of material that we have tested. And these selected materials are basically the ones that become our starting point. So generally speaking, we are already starting at a higher point for breeding, and then we'll take it forward from here and bring it even further through various targeted recurrent selections. Next one, please. Also, while we do our advancements, we track the major genes. This is just an example of one of our, germplasm tracking. Some of the major genes QTLs you are well aware of. We are regularly tracking them when we advance our lines through the breeding program, and we make sure that we maximize the proportion of favorable alleles of these QTLs, and make sure that we make the most use of those earlier genetic studies that have been done. Next one, please. I will stop for a moment here and talk a little bit about the DSR phenotyping infrastructure. We discussed a little bit about the AICRP, and how we need DSR specific trials in AICRP so that we can advance the relevant material. We have identified this as a critical aspect, and we have actually established phenotyping systems in India, in Kenya, and in the IRRI headquarters. The picture that you see is one of that. That is from our breeding program in headquarters. And what we see is that end-to-end mechanizations can be taken care of and in these systems. And we are having experts who are working in Hyderabad, etc., where we are designing proper fields, we are designing irrigation systems, we are putting end-to-end mechanization for breeding operations, and we are making sure that we select the relevant germplasm under the relevant systems and then take it forward. And all our partners are welcome to look at it and see, what is working for their breeding programs and what may be good for them to adopt and so on. So you're most welcome to visit us at any point and join us and even provide your feedback, how you would like us to mechanize it further and so on. Some of these aspects will be taken care under 2 of our new projects that are Plant Direct and Scale Direct, where we are actually working with the partners in terms of their mechanization, initiatives as well. Next one, please. This is just a glimpse of our DSR breeding network. We have close to 40 sites which span across Southeast Asia, Africa, and South Asia, and even at actually Central Asia as well. And we are making sure that we take all the learnings and experiences from various places to design our program better. And we basically try to bring all the relevant germplasm and things that are required in these regions. And all our partners are together in this testing effort that we do across the board. Next one, please. I think, Virender, I'd ask you to take this one up, please. Thank you.
So thank you, Salab. As Salab pointed out, how important the breeding is to push the DSR yield frontiers. It's very, very critical. At the same time, we thought of, new varieties may take time. So within existing varieties, which are working better, which are better adapted or performing better. So we through several partners, and you can see the logos we are working with for variety testing under DSR of the existing varieties, and don't have time to present state-specific results. But what we observed overall, that hybrids gave higher yield than inbred overall. So it's about 16% higher yield in hybrids we observed. We also observed that hybrids were also more weed competitive because of early vigor. And, we identified state-specific varieties, whether it's inbred or hybrid, suitable for DSR within existing release varieties. And from some of the green super rice material of IRRI are performing good under DSR, like Biridhan 75, Binadhan 17, PR 126 from PAU. And these are the varieties, in Punjab, Eastern UP, Bihar, West Bengal, Haryana, whether it's a hybrid or inbred or basmati or non-basmati, performed really good under DSR. Second important point after variety is risk reducing practices, because one of the reasons why adoption is low is because of risk of poor crop establishment. As I said, in transplanted rice, you have assured crop establishment because of transplanting method. But in DSR, you're directly seeding it. Whether crop will emerge or not, there's several factors can affect. If you look at, risk, poor establishment due to inundation caused by unpredictable rain, because rice is grown during monsoon season. So if get flooded, poor establishment, what is the solution? How we address this risk? One approach is breeding solution, having varieties with anaerobic germination tolerance trait. But currently we don't have the varieties available to the farmers. It's in pipeline. It will be likely once the varieties are released and available, then can be used. But right now farmers don't have access of AZ tolerant varieties. So this is what we call pipeline solution, not current solution. So other solution is, can we establish early, about 3 weeks before onset of monsoon or heavy rain starts, so you escape that risk of flooding. You can do that, but there's a trade-off. And the trade-off is that, because that's a very high temperature, high evaporation rate, so high irrigation requirement. And that's how you can address this trade-off. And this is the technology, what we call water DSR in local language, or soil mulch DSR. So it's basically the till, like pre-sowing irrigation, then under field condition, you prepare the field, and that till is basically break the capillaries, and that conserve the moisture below 2 centimeters. So in that way, you can avoid your first irrigation by 2 to 3 weeks, and hence enable early sowing. So you don't need to worry about irrigation. One investment of pre-sowing irrigation, and then you can delay for 2 to 3 weeks, and then you expect rain to come and you're fine. So this is what we call soil mulch or water DSR. We worked with the Punjab Agriculture University and the CISA and also Vishwa Bharati University to see the impact of water DSR or soil mulch DSR. With PAU, we'll look at how many days we can delay first irrigation under water DSR. And you can see the first figure, the yield was similar whether you irrigate immediately or 2 weeks after sowing or 3 weeks after sowing. So you can delay up to 3 weeks under Punjab condition. And it has a positive impact in terms of weed suppression because surface is dried, 2 centimeters is dried. So weed recruitment or emergence is very, very low, about 60 to 70% less weed density in biomass when you delay for 2 to 3 weeks. And then there's a further water saving because of delay of your first irrigation. If you delay for 3 weeks, up to 11% water saving. In rain-fed condition, that was irrigated condition. In rain-fed condition, we observed that yield was higher under water DSR compared to a normal dry DSR followed by irrigation. So, and also 40 to 60% less weed infestation and water saving. Another way of, for futuristic, this work we did with CSSRI, and this is screening a lot of varieties or lines for anaerobic germination. And you can see that it's very promising. There's some lines which has up to 80+% emergence under continuous 10 centimeter flooding depth for 2 weeks, immediately after seeding. So these lines could be a good donor for breeding for anaerobic germination tolerance, which is very, very critical for DSR. Another approach of reducing risk is seed priming. And this work we did with PAU and with Vishwa Bharati University. And what we observed that, halo priming with potassium nitrate or hormonopriming with GA3 can increase yield. And this increase was primarily because of, rapid emergence, better root growth, and good establishment. And we also observed because early vigor, we found 20 to 40% lower weed biomass. On weed management, weed we know that is critical for adoption. That's one of the major bottleneck farmers reluctant to adopt DSR. But great progress has been made. And that's why we're talking about scaling DSR. So we have solutions now to control weeds. And I think pre-emergence followed by post-emergence and one-spot hand weeding provide effective weed control in DSR. The problem is still the knowledge, because it's knowledge intensive. In DSR, there's a diverse weed flora. Which herbicide to select to apply based on the weed flora is a knowledge intensive. How we make that knowledge into more a practical solution? We are working on a mobile-based app, which can help farmer based on the mixed weed flora, what herbicide to select. So that's in pipeline. Otherwise, we have the solution which can control the weeds. And we are also working around drone-based spraying, the SOP for herbicide application. One of the scientists from ICAR-IIRR is now working with me at IRRI. He's a postdoc, and his major focus is going to be on developing SOP for drone-based spraying. Herbicide tolerant rice is another, kind of solution emerging. So that will boost adoption of DSR because it will address the problem of weed, which is the major bottleneck in adoption. So it will overcome the weed control issues, and herbicide tolerant technology has been developed by IRI, and they have already developed basmati variety with HT traits. And some private sectors like Savannah Seed and BSF are also planning to deploy this technology in India. We worked with the HAU and tried to come up what are the herbicide treatment optimal for HT rice in hybrid, like non-basmati. So in basmati, Dr. A.K. Singh and team are working. So they have also optimized the herbicide recommendation. For non-basmati, but we observed that imagethapir 2 times early in late post-emergence, either 125 gram, or you can go with 100 gram and 150 gram, or you can go with imagethapir followed by premix of imagethapir plus imazamox. So any of these treatments can provide pretty much similar to weed-free conditions. We also looked at if there's any carryover effect of ICAR-IIRR, because this is a residual herbicide, longer residual effect. But in rice wheat system, in IGP, we didn't found any negative effect of ICAR-IIRR on either wheat, mustard, lentil, maize. So it's safe to grow these crops after rice in at least northwest side of the country. But I think we cannot use this technology as silver bullet. We had to develop strong stewardship program for long-term sustainability of this technology. And last time I had discussion with Dr. A.K. Singh, and we will be probably Directorate of Weed Research and IRI and other partners can have brainstorming what could be the stewardship program looks like for HT rice in India. So another component is scaling, and scaling is so critical, and I invite my colleague Dr. Sudhanshu Singh to talk about scaling. Dr. Sudhanshu?
Thank you, Virender, and thank you everyone for inviting me. And as already our scientists and the leads from ED headquarters, Virender and Salab has explained the science behind it and what the new innovations that are taking place in collaboration with the many stakeholders and at various countries. And we are lucky that all those things are pouring into India or South Asia as well to scale. Through ICAR, we are coordinating the scaling activities, and we do follow an integrated approach involving all of the gametes of the dissemination and involving most of the tools that are made for that. Starting with using the GIS and remote sensing or geospatial intelligence for suitability mapping, the big demonstrations where we are working very closely with the national system as well as ministries and state governments, creating service economies through various projects, and that's not only with and also involving the already existing service provider for those economies. Adaptive strategic research, already Virender and Salab has explained the capacity development that we are doing for the partners, and not only the NRS and government, but I am happy to inform that even the private companies like Bayer, Khartova, we are involved with them, and we are doing TOTs kind of things for them, developing strategic partnership, actionable knowledge material, and finally the enabling policies, incentives, and learning. Next, Virender. Virender, can you change the slide? Yeah, thank you. So starting with the first DSR area mapping and suitability approach, if you see for the success of any technologies, and especially if you want to introduce anything, the proper targeting is very much required. And so for technology targeting, we are doing both the characterization as a biophysical characterization as well as technology available in space, means during the extrapolation and those kind of things. So if you see, we are in biophysical, we are doing area mapping, we are finding the suitability based on soil type, and we are means which soil to avoid also, that's not fit for the DSR. And for technology means machine distribution, creating service economy, involving service provider of zero tillage and others, all are well integrated. And these are the examples where we have already done some area mapping in some of the states where the like Mayurbhanj or Odisha or some states where this is already very much integrated approach has been adopted for the proper targeting, and we really can pinpoint the areas where we should go first, if based on not only the suitability of the area but also the machine existence of the machine or the existence of the service provider also, as well as the social and cultural aspects also that suits to the DSR. So based on those, these maps have been created. Virender, next. And then bringing the small scale things for a technology like DSR, which requires an impact at scale, will not serve our purpose. So here, what we are aiming is to have a big demonstrations, hundreds of acres demonstrations, as like 50 or 60 or 100 acres in one row. This particular example, if you see in Odisha, we are working very closely with the Odisha government, and this year means in 2020 alone, we conducted or we achieved 3,000 acres of new DSR plots. And all those plots or cluster demonstrations are stretched with at least 50 to 60 acres of land. And that create really a huge impact, one for the policymakers, the bureaucrats, as well as farmers. And it is easy also to scale, because you can bring the farmers and you can do all those trainings and crop cutting events also very successfully. And this tweet I want to highlight. This is a tweet from Arvind Padi, the Agriculture Secretary of Odisha. And this is our DSR cluster demonstration. Seeing is believing. So you can see the tagline and the impact that these demonstrations or the cluster demonstrations are creating. And those kind of things, if we are really successful in doing some of other states, I do see that DSR could be scaled out very quickly, and we can achieve the big percentage. Next slides. And definitely the technology alone can't change the game and can't do all magics or creating the demonstrations fully supported by a project. We do need the service economy, and very robust service economy driven by the entrepreneurs, driven by the public, driven by the private players, as well as farmers. So that aspect is also well being taken care of. And that's the key for increasing access to capital intensive technologies, because if a project leaves, suddenly you will see the drop in the areas, or the policy incentives subsidize or finishes, there is a sudden drop in that area of that technology. So thereby we are really aiming to create a robust service economy, and it also create the employment opportunities for the youth. And so we are not only creating the new service provider for DSR, but we are also relying to involve the existing service provider. For example, through CISA and other projects in Bihar, we have almost 3,000 service provider for zero tillage B. Now, from last couple of years, we are trying to bring in for the DSR kind of things also. And I'm happy to inform that almost 11% of those zero tillage wheat service provider are already involved in the DSR service provision for the rice in Bihar. Virender, next slide. In Odisha also, we have created almost 200 DSR service provider in last 1.5 years. See, this is the one analysis I would like to highlight or to draw your attention, and this is ex post analysis to understand the constraint in wide scale adoption. And we all see that in some areas there would be sudden abrupt increase in the area of DSR, and then suddenly you will see some farmers will stop doing DSR. So and there are failures also. So we did some surveys, and there's a large scale survey in 4 states. And then farmers reported some of the factors. If those are resolved, that would really help in the larger adoption of DSR in different ecologies of 4 areas of Bihar. And that's the 4 agroecological zone of Bihar that I'm mentioning. And invariably in most of those areas, if you see some of the like assured irrigation, better herbicide availability, machines availability, demonstrations, those are the major things that's invariably coming up in irrespective of the ecologies. However, there are some variations also. The bigger font is the more emphasis of the farmer was on that, like on-field support or better access of seed drill and tractors was also coming invariably in some of those areas. So those are the points that emerge, and if we really work on those aspects, I don't see any reason that why we shall not be able to quickly scale out DSR in next few years' time. Virender, next. And then TOT, I have already spoken that capacity building is our major focus, and not directly with the farmers, not to that extent, but really creating the trainers for those, and we are developing the modules. We are working very closely with the organization like Jivika in Bihar with millions of women farmers to train their staff, and we are training them in the batches at ICAR. Training for the technical staff of like Bea, Khatova, those private companies, and these are all fully paid training. So that also create a lot of interest with the week-long training, and they get really fully acquainted with all those technologies. like NGOs, the Reddy Foundation staff training that was again done last year at ICAR, with almost of their technical staff trained on DSR. Virender, next slide. So, Virender, can I go ahead with that or you?
Yes, please go ahead.
Yeah, thank you. So there is no denying that DSR is the need of the day. Transplanting was brought as a weed control measurement for those rain-fed and irrigated ecologies, but definitely seeing the world trend, the future of rice production will definitely rely on DSR, being the climate resilient, being the resource efficient, and then farmer friendly technology. Progress has already been made, closing the yield gap, and you have seen the Virender's and Salaf's presentation. We are aiming even the bigger, even the advantageous DSR in terms of yield and profitability. The gaps, especially precision establishment, weed control, and risk reduction, has already been minimized. There are great scope to improve farmer income and environmental sustainability, and there is no denying that precision DSR would bring all those benefits. Public-private partnership network that's DSRC has created globally. Virender is leading that. That brings huge opportunities for cross-learning. Salav is also leading a breeding network on the breeding globally. So those kind of network will address the complex issue related to the DSR and opportunities to innovate, catalyze, and create a big impact using DSR. Thank you.
Now I request Dr. AK Singh, who has joined just now, sir, for your remarks on DSR, sir. We are all waiting for you. Dr. AK Singh, sir.
Thank you very much. I have 2-3 slides that I would like to share. Of course, most of the points have been already made, so there is nothing new to add actually in whatever has been said. We all, understand DSR is important, and this has to be posted, and we have to have a national plan for it. That is extremely important. So, yeah, can you see my slide? Can you see my slide?
Yes, sir, we are able to see it, sir.
Yes, sir.
Go ahead,
Okay. Sir. So the major problem, as has been outlined earlier, the poor crop stand because of, the rains sometimes that happens post sowing and the crust formation, that's a concern. Weed infestation, iron deficiency, and susceptibility to, several biotic stresses, particularly root knot nematode and blast is likely to be more exaggerated situations in case of DSR conditions. And we, of course, have a ongoing project on development of dry DSR varieties. And there the target is, of course, on anaerobic germination, herbicide tolerance, root system architecture, the genes like DRO1, DRO2, Bacane resistance, number of putules, blast, root knot nematode genes, drought tolerance. So all this put together, this is one DVT project that we are doing with the department, with Punjab Agriculture University, with a focus on converting most of our lead basmati rice varieties into ready to use for DSR situation. They are already doing, in fact, many farmers are doing, and the targets, for example, in Haryana and Punjab this year, it's going to pick up in a big way. These are the different genes, markers, locations, and sources that we have planned. And using the strategy of the classical marker-assisted backcross breeding of simultaneous but stepwise transfer, we are aiming to bring in dry DSR suited varieties in future. One of the major concern that has been is that of weed, and you all know that we had a DBT funded project, network project, wherein starting 2008, the herbicide tolerant mutants were identified in Nagina 22. And Dr. Robin at TNAU identified the mutant, and subsequently the mutants have been mapped, tagged, markers developed, and transferred to a number of genetic background. Different institutions are doing. National Rice Research Institute, Cuttack is at advanced stage, Indian Institute of Rice Research is doing. Then, of course, TNAU is coming out, and mostly in this non-Basmati background. In Basmati background, we have developed 2 varieties. One is improved version of Pusa Basmati 1121, which is Pusa Basmati 1979, and one is improved version of Pusa Basmati 1509, that is Pusa Basmati 1985. So these two have been released as a matter of fact, but currently this when gets combined with already their version available for resistance to bacterial blight and blast, which have been released like Pusa Basmati 1847, 1885, 1886, in the most good agronomic background, bringing HT trait is not along with the resistance to diseases and also drought tolerance that is available in the background. So putting all these together will not be difficult, and we should be having the varieties suited for this condition very shortly. Now the question is that the expansion of label claim for this herbicide. And we have a network in which number of centers are participating. The expansion of label claim has to be applied by certain companies only, and we are in touch with Adama. Adama has filed the application for expansion of label claim to CIBRC, Central Insecticide Board Registration Committee. Unless this expansion happens, we cannot recommend the use of imidacloprid on the herbicide tolerant rice varieties. So this is one thing that is pending. I was hoping that before this crop season, we have the expansion of label claim given, and then we have plenty of seed produced for both these varieties which have already been released, and we could conduct maybe several thousand acres of trial with herbicide tolerant rice varieties. But still this is going slow because there is a big backlog with the CIBRC for different application, and we are trying to push it forward at the earliest possible. I think another very important area where seed enhancement for DSR related problems is going to be very, very important, and that's where I think a lot of research is required. If something can be done for nano formulation of iron coated on the seed of rice so that the iron deficiency is taken care of. Likewise, many nano pesticides at seed treatment would be very, very effective in the DSR condition. So I think that's what I had to say at this point of time. And we all realize the importance of this technology. We need to make a massive campaign. In fact, before this crop season, at least with the available technology, and the available technology is, the sowing window starting from in northwestern part of the country, sowing window starting from 25th of May to 15th of June. This is the recommended window. And, with pre-sowing irrigation with Tarbatar method, use of pendimethalin and later Nomni Gold, and seed rate of 8 kilogram per acre with especially designed seed drill, or even farmers are going for broadcasting. So this is very standard practice now. A lot of farmers are adopting. And if this is done timely, the weed control can be done, but many times the operations are not done timely, and therefore weed becomes a major problem. So with that, I would like to close my remarks, and if there is any specific, discussion, I would like to certainly address those.
Thank you very much, Dr. A.K. Singh. Thanks for your very insightful remarks and also highlighting the progress related to development of herbicide tolerance rice, which is an important requirement for DSR. Sir, I request you to kindly stay with us. So after a brief presentation about what we have learned from AICRPR trials on aspects related to direct seeded rice by Dr. Mahendra Kumar, we'll be having focused discussion on some 4 or 5 important topics. I request Dr. Mahendra Kumar to start his presentation. Say maybe within 8 to 10 minutes, you can finish it, sir. Thank you.
Very good morning to everyone. I think I am seeing.
Just to check up whether you're audible, sir.
Am I audible, sir? Anybody can?
Yes, you are. You are.
Okay.
Please go ahead.
Thank you, sir. Thank you. Just I will be. I think my presentation is made very easy. I will not dealing again the points raised by earlier speakers. And one good thing is we are having one exclusive DSR team at IIRR who are from different disciplines who will be working working on the DSR activities at IIRR and also active program. Next, please. I will be next. Go ahead. Next. These drivers, as I think already Virender has already pointed out. And this is one of the reasons, main reason for we are shifting towards and wherever when there is a lot of labor shortage, and I think in Punjab you can see that even 10 lakh hectares was converted into DSR, but slowly it has now come down to 6 or 6.5 lakh hectares. So we have to think about how best this DSR can be improved even with the labor availability also. Next, please. When we are talking about DSR, we need to think about what type of DSR we are cultivating it. So that is more important. So to try the varieties which are being developed for one system, but DSR is a lot of variability, as even Dr. A.K. Nayak told. When many modifications of DSR are there, then we have to think about before recommending any technology for this DSR. These are the, I think, different methods of DSR, and also within the DSR also, when we are sometimes we go for dry sowing, then we later will convert into totally wet under fed system. Like that, many variations are there, but if DSR can be managed properly, we can get on par yields of the transplanted rice system. These are some of the, I think already somebody has pointed out, we are having more than 10 million hectares of DSR, and it will further increase, but we need to see that the stable yields have to be achieved with the DSR. Then only this technology can be sustained. I will be skipping these constraints, and then traits have been already covered by our own previous speakers. This is one of the very critical input, I think, which is required for DSR for better yield. That is anaerobic generation. That is very much essential. In many places, we have seen that because of this, there is a lot of reduction in the yields. This has been and it has been already, I think, NRRI, even IIRR are also working on this herbicide tolerance. We most probably will be getting very good material, which can be a game changer in DSR promotion in a very big way. These are the, I think, activities carried out at IIRR in our farm, and we are able to develop very good lines, which are very promising and dry DSR conditions. Next, okay. These are the varieties, sir, which have been released. One hybrid we have of late we have released very recently, and it is very promising, and we can get very good yields, more than 6.5 to 7 tons under dry DSR conditions, and it has been now already notified and released. And we have some good varieties also at Indian Institute of Rice Research. Only thing is, with our programs like Tribal Sub-Plan and SCSP plan, we can promote this varieties so that we can save a lot of resources for the rice cultivation. These are some varieties we have tried, as suggested by even Virender. We are able to get very good results when hybrids are taken in the DSR conditions. They could be able to respond well under DSR condition because of early growth and covering of crop canopy to a great extent by 30 days. And they are suppressing a lot of weed flora, so that they can get a very good yields of under DSR conditions. And we also tried for last 4 or 5 years. We could able to evaluate many very good number of herbicides which are very effective for dry and wet DSR. And we are also started one weed survey of this different establishment methods, and we found that lot of shift in the weed flora under wet DSR. Even we are seeing some of the promising species are emerging in DSR system, which is very difficult to control. Then these things has to be identified and to plan properly for effective management of the weeds. These are the prerequisites for DSR, success of DSR. Very level fields are very much essential for DSR cultivation for proper crop stand. Unless you maintain crop stand, it is very difficult to get the better yields under DSR condition. And we are very happy to share with you that we are associated with one of the NGO where we are, I think, closely associated with them, where we are cultivating more than 10,000 acres of DSR, dry DSR, and the yields are ranging from 5 to 6 tons. and it is a mechanized, totally mechanized from seed to seed. And there is a saving of more than 10,000 to 12,000 rupees per acre, the cost of cultivation. These are the equipments which have been used. Only thing is how best we can promote these customized equipments to the upscale the technology. And everything is mechanized, and we can able to do this more than 2,000 acres within a span of 2 to 3 days. Everything is mounted on tractors, so we can easily make this DSR viable at that particular area, and this can be really upscaled in across the country. And these are the problematic weeds which are been emerging because of DSR cultivation, which needs to be focused. Effective control of these weeds must be taken care. These are the herbicides which I think already have informed. You can clearly see that some of the areas, even still, we are not able to control it even with herbicides and herbicides which are being used. Even we have tried some multi-location trials across the country with DSR compared with normal transplanting, and then there is a lot of difference in the population of the pest populations and pest damage, and which need to be focused. Not only nematodes, there is a lot of changes in the occurrence of the pests in this because of the DSR cultivation. You can clearly see that whenever, because of high population, the leaf folder damage is much more higher in the DSR cultivation. And we could able to, our analysis told that we can straight away reduce more than 25,000 rupees per hectare with the DSR cultivation. This has been done our economist. And now we are doing it. Water management is which plays a very important role. We are now working on IoT based, sensor based water management. We can easily monitor the depth of water depletion, and we can we can give the input of water as per the requirement of the crop growth. This we are also tied up with one of our startup company, Cultivate, based at Bangalore. Now these things will be utilized in our DSR promotion. And we are also trying to see that drones, how drones can be used for broadcasting, even for using for micronutrients and nano spray, so that we can reduce further labor requirement, and we can also improve the productivity of the DSR system. I think these are the, I think already many of the people have covered it. We need to think about best varieties suitable for DSR cultivation. And some of the traits is the root system is also very important. And total mechanization is a very good solution to upscale the technology. I think this is all about what we have done at AICRPR, and we are very much eager to know what we can do in future under AICRPR system, so that a stable DSR yields can be obtained from the farmer fields. Thank you.